Hi, here's section 9.9, the review problems, and it's 2B, and this is an interesting problem. I don't think we've done one quite like this before. I think I'm gonna cheat a little bit on this, so let me just show you the way I'm gonna set this up. First of all, I'm just gonna think about what's happening here. Okay, here's my axes right here, something like this, right? And I know that the first foci, let's just say it's over here at 1, 2, 3. So it's going to be here at negative 3, 0, and then 3, 0 right there. That's foci 1 and foci 2 of the ellipse. Now, I don't know where the ellipse is. I'm just going to take a guess that it's something like this. I don't know. All right. I know that looks more like a hot potato or something, but we're going to just pretend this is an ellipse. Oh, wait, I can pretend a little better than that even. Wait, let me even take that off. Because look here, the major axis is 10 units. If the foci is on the x-axis, then I know that the semi-major axis is going to be 5 units, so 3, 4, 5. I know right here this is going to be the end point of my ellipse, right here and right here. So I know the ellipse, I know even better, it's going to do something like this. Now my problem is, what I don't know is where exactly it's going to cross the axes up over here. I don't know that point right there. All right, but I do know the foci. This is the first foci number 1, and this is the second one at 3, 0. And I know the length of my major axes from here to here, that length right there, this length right here, that length is 10 units, whatever it is, 10 centimeters, 10 inches, whatever, it's 10 units, okay? So let's now think about what has to happen here, and this is the part where I'm going to cheat. Because if I know that, then listen, let's just make this perfectly even, okay? We know by the geometric definition of an ellipse, we know that this distance right here, right, plus this distance right here, this distance right here, those two distances, d1 plus d2 has to equal the length of my major axes right here. That's the geometric definition of an ellipse. Okay, so, and we know that that's 10. It's 10. Now, the thing is, the reason I picked this point up here, remember a couple of reasons. One is because, look, this point right over here, we know the x-coordinate. The x-coordinate is 0. Now, we don't know the y-coordinate. We'll put a y right there because we don't know what it is. The x-coordinate is 0. The y-coordinate is y because I don't know. All right, but I do know but I do know that d1 and d2 here are going to be equal at this place right here. If I pick this point right here, those two are going to be equal. Okay, so that's interesting. All right, so let's work with d1 plus d2 equals 10. Now, I'm just trying to keep this as simple as I possibly can. So I'm just going to use the distance formula. Distance for d1. d1 is going to be the distance between this point right here to this point up over here, 0y. Remember the first foci is negative 3, 0, right? Negative 3, 0. And so the distance is going to be change in the x-coordinates. So it's going to be 0 minus a negative 3 squared, right? Plus the change in the y-coordinates, which would be y minus 0 squared. So it's just y squared, right? So plus, now let's do distance 2, right? Distance 2. This one right here, distance 2. Okay, remember this is the points 3, 0. So let's do the change in the x-coordinates, 0 minus 3 squared, right? 0 minus 3 squared, because that's the change in the x-coordinates, plus the change in the y-coordinates, y minus 0 squared, which is just going to be y squared. All of this is going to equal 10. Now, 0 minus a negative 3 is the same thing as 0 plus 3, and 3 squared is 9. So really what I have here is radical 9 plus y squared plus, now look here, negative 3 squared is 9. So look here, I got the same thing, which is so sweet. This is why I did this, because see, these two distances are equal, d1, d2. This all just makes sense, doesn't it? They're equal. So I'm going to get 2 times radical 9 plus y squared equals 10. So see, now this isn't too bad to solve, right? So I can divide both sides by 2, and so I'm going to get radical 9 plus y squared equals 10. I kind of ran out of room there. Well, here we could just flip the page, I guess. And I'll go back if I need to. So radical 9 plus y squared equals, oh, did I say that was 5? Because when I divide it by 2, oh yeah, no, what am I doing? See, I don't have you guys all to help me here. This should be 5, right? 10 divided by 2 is 5. All right, now we come over here, we got a 5. Now we're going to take this, we're going to square both sides here, square, right? And so we get 9 plus y squared equals 25. You know, because the square root of something squared is just the something inside the square root. And so we can see here y squared equals 25 minus 9, 16. And so y is going to equal a positive negative 4. Now let's go back and look at y. Why does y equal positive negative 4? Look, we kind of knew that, didn't we? I mean, didn't we sort of know that somehow? Did we figure that out somehow? Yeah, because look at this. Look at this. See, I could have reasoned that out earlier. I could have like really super duper cheated, but I didn't, but I could have, because watch. See, this is a 3 right here. This is 3 units, right? And I know that D1 equals D2. Since D1 equals D2, okay, that it has to be 10. I knew that D1 had to be 5. This distance here had to be 5, and this distance here had to be 5. And so look, I knew this had to be a 3, 4, 5 right triangle. 3, 4, 5 right triangle, see? So I could have guessed that 0, 4 is where this ellipse is going to go right over here, and then 1, 2, 3, 4 should come down right over here, and it should come right there. But still, look, my potato wasn't too bad. And 0, negative 4. All right, but are we done? No, of course not. Of course we're not done. We haven't written an equation yet. But still, there it is. That's the whole ellipse right there. You see it? You see it? So writing the equation isn't so bad, right? So let's do it in black. Let's actually pick a different black for a change. Okay. All right. So this is the equation of the ellipse, and what I'm going to get here is the ellipse. It's centered at 0, 0, right? So it's going to be x squared over, and the length right here, remember, is 5. From here to the end is 5. So it's going to be over 25 plus y squared over, and remember here is 4. So it's going to be over 16 equals 1. There's the equation right there, right? That's the ellipse. Now to make it a polynomial equation, to give it integer coefficients, I can multiply both sides right here by 400, right? Why do I multiply by 400? Because 25 times 16 is 400, right? So 25 goes into 400 16 times, so I'm going to get 16x squared plus 16 plus 25 x squared equals 400. There it is, done. All right, a little bit of cheating there, but you know, it works, and that's way better, way better than picking some random point on the ellipse. Like if you pick a point right here, x, y, you just have fun with that, solving that square root. It can be done, but just saying, this is just a little bit more fun. All right, take care. Bye.